All right, we're going to start dealing with rational expressions. A rational expression is a fraction formed of two polynomials. You've previously only dealt with fractions that were made up of integers. So, as we consider polynomials, we have to think a bit more about what is meant by least common denominator. So for integers, when you talked about the least common denominator, it was simply the lowest number, denominator, which is divisible by all denominators that you start off with in the problem. And generally speaking, this was pretty easy to find. For algebraic expressions, this is going to be trickier. The least common denominator, if we're dealing with rational expressions, will be the least degree polynomial, which is divisible by all of the denominators. And since we're talking polynomials, of course, this is going to require factoring. Now, before I show you some examples of how you might find the least common denominator for rational expressions, I want to just do a couple quick examples of how this works with fractions. I'm going to go through these pretty quickly. So right here, there are some very simple examples of how you can find the least common denominator with fractions. Perhaps the simplest is if one of your numbers is an integer. Here, to convert 7 to fourths, I multiply by 4 over 4. You can put 7 over 1 if that helps you, although it's really not necessary. So what does this give me? This gives me now 9 fourths minus 28 fourths, which is negative 19 fourths. Okay, that's a simple example. Another simple example of finding least common denominator is if one denominator divides the other. Here, 3 divides 6, so how can I convert this? Well, pretty obviously what I need to do is convert thirds to sixths. So I multiply by 2 over 2. What will that give us? Well, that will give me 14 plus 1 over 6, which is 15 sixths. And as with all fractions, we should look to simplify this. 15 sixths, both of those are divisible by 3, so I get 5 halves. Now, of course, most of the time, when you dealt with these problems, it was pretty easy to guess what the least common denominator was. Here, if I gave you this next problem, 5 twelfths plus 9 twentieths, well, again, you could pretty easily just look at these numbers and tell that 12 and 20 both go into 60. But let's take a more systematic approach to this. 12 and 20. So if I want to do this, the best way is to think about the greatest common factor and how these factors differ, how these denominators differ. Well, 12 and 20, I know, are both multiples of 4. That is their greatest common factor. 12 is 4 times 3, 20 is 4 times 5. So my least common denominator is going to have all of those as factors. Because again, going back to the definition, the least common denominator must be divisible by all of the denominators. And it's the simplest such denominator that is divisible by all denominators. So, a denominator that's divisible by 12 will have to have 4 and 3 as factors. A denominator divisible by 20 will have to have 4 and 5 as factors. Which means my least common denominator here needs to be divisible by 4 and 3 and 5, and I don't need anything else. Now, if you're wondering, of course I could break 4 down further into 2 and 2, but there is no need in this problem since 4 is clearly the greatest common factor. Anyway, 4 times 3 times 5, that is 60. So what I want to do here in converting this is think about, okay, how do I get twelfths to 60ths? How do I get 20 to 60ths? Well, I can see right here that 12 is 4 times 3. So if I think about the fact that this is missing or it needs a 5. And for 20, I can think about the fact that 4 times 5, well, that is missing the 3 over here. So this needs a 3. So that's what I'm going to do. That's how I'm going to convert this. I'm going to write this right over here. 5 twelfths, that needed a 5, so I'm going to multiply by 5 over 5. 9 twentieths, well, 20 needed a 3, so I'm going to multiply by 3 over 3. Now, what do I get? I can see right here, at this point I'll have a common denominator, so I'm going to go ahead and just write it over a single denominator, 60. 5 times 5 is 25. 9 times 3 is 27. 25 plus 27 is 52. And I will simplify 52 over 60. 52 over 60 is, of course, 26 over 30, or 13 over 15. And I could have simplified that in one step if I had thought a bit more and said those are both divisible by 4. But either way, I got to the right answer. So again, this process of finding the least common denominator and converting fractions is going to be extremely important when we move to more complicated things where the denominators are algebraic expressions. let's take a look at something that's not obvious. For 12 and 20, you probably could have just written out some numbers and figured out 60 eventually. But if I showed you these numbers, 245 and 105, these are by no means obvious numbers. What common what common multiple do they have? I have no idea. So what I'm going to do is try and factor these. So I know that 245 is 5 times, and you can figure out that it's 5 times 49, which means it's 5 times 7 times 7. 105 is 5 times 21, which makes it 5 times 7 times 3. So when I'm trying to come up with a least common denominator for these fractions, I can see that clearly these two fractions have a 5 and a 7 in common. So that needs to be part of my least common denominator. Now look where the denominators differ apart from that. 245 has another factor of 7. In other words, 49 is a factor of 245, so 49 needs to be a factor of my least common denominator. For the 3, again, 3 needs to be a factor of my least common denominator, so I need to multiply that in. So what all do I get here? I get 49 times 15. 49 times 15 is, oh boy, that's embarrassing. What is 49 times 15? I'm blanking here for a second. Pulling out the calculator, 49 times 15 is 735. All right, so that's my least common denominator. Now, again, if I think in terms of 245 and 735 and 105, this is a difficult problem. But if I think in terms of, I know that these are the factors of 245 and 105, and I know what I'm missing. What is this missing? A 3. What is 105 missing? A 7. So what I'm going to do is come over here and say 22 over 245 times 3 over 3, because that's the missing factor. Minus, not plus, minus 8 over 105. Well, 8 over 105, 105 was missing a factor of 7. So I'm going to multiply in a 7. So when I do this, what do I get? Well, I get 66 minus 56 over 735, or negative 10 over 735. And again, you should always simplify your fractions. 5 is clearly a factor of the numerator and the denominator, so what I get is negative 2 over, excuse me, 147. Negative 2 over 147. So again, we need to understand how to work with fractions to do what we're about to do. As I said, we're looking at least common denominators for rational expressions. For algebraic expressions, I need a denominator which will be a polynomial, which means this is going to require factoring. Now, before we dive into this, we're going to be considering problems such as, how do I find a least common denominator for something like this? And so forth. It will involve factoring, and if you're looking at this, you can tell, okay, there's a GCF of 3, so that'll be part of my work there. Well, before we dive too deeply into that, something you need to consider. We are factoring, and you need to understand that for polynomials, x, x minus 1, x plus 1, 2x minus 1, these are all distinct factors. That is to say, there is nothing, no polynomial I can multiply with x to get x minus 1. X is not a factor of x minus 1. We've been factoring all year. You know that if I get x minus 1, I'm done. That cannot factor further. Similarly, x minus 1 and x plus 1 are not factors of one another. And just the same, you're seeing x minus 1 and 2x minus 1. Well, of course, 2 times x minus 1 is not 2x minus 1. It would be 2x minus 2. So you have to think about these things logically. You've been exposed to factoring throughout the entire year, and you need to retain those skills, because that's what this all relies on. So I'm going to show you a couple examples of rational expressions and how you might find the least common denominators. One of the big things that we will be doing in the future is adding and subtracting rational expressions, which is where this is going to come into play, as well as several other things in this unit. But least common denominator is a big thing. So, right here, I'm going to cover up the problems I'm not using to try and make it easier for you to see. So here, my denominators are simple. x plus 3, and x minus 4. Now, generally speaking, with fractions, when you're working with them, you should try and simplify them first. But notice, these do not simplify. You see here 4 and negative 4, and it's tempting, but 4 is not a factor of x minus 4. X minus 4 is already factored. It is not 4 times something. I cannot simplify this. So instead, I need to consider my least common denominator. Well, if these denominators are both factored, and they're both distinct factors, then my LCD, my least common denominator, must be x plus 3 times x minus 4. Which means this first expression is missing an x minus 4. This second expression is missing an x plus 3. So when I write this out and try and convert, here's what I'm doing. I'm taking 2 over x plus 3, and just as I did when I multiplied by 3 over 3 or 4 over 4, here I'm going to multiply by x minus 4 over x minus 4. For the second expression, the missing factor is x plus 3, so that's going to be multiplied into both the numerator and the denominator. Now, at that point, I will have a common denominator, so I can write this all over x minus 4 times x plus 3. And what I have up here is 2 times x minus 4 plus 4 times x plus 3. And if you distribute this carefully, you will get the final answer that we'll be arriving at again when we really do this in a few days. Up here, I should have a total of 6x plus 4. And in the denominator, I should have x minus 4, x plus 3. That's what I get if I multiply that out and combine my like terms. But again, focus on that process of finding the least common denominator. Let's take a look at another example. Here, arguably a simpler example even. My denominators are x cubed and y squared and x and y to the fifth. So the idea is, again, my least common denominator needs to be divisible by both denominators. Well, I see here I've got x cubed and here I've got x. Since x cubed is a factor of this denominator, it needs to be a factor of my least common denominator. I need to go with the highest power of x in any of these denominators, which is x cubed. I also see y squared and y to the fifth, which means I need to go with y to the fifth in my common denominator. Now, what do I do at that point? Well, I consider here x cubed y squared. How different is that than my least common denominator? Well, I'm missing a y cubed. X y to the fifth, there I am missing an x squared. So just the same as I did before. 5 over x cubed y squared, and you're going to multiply in that missing factor into the numerator and the denominator. Same thing with 7 over x y to the fifth. This was missing an x squared, so I multiply in an x squared. So at this point, I now see this is a common denominator. This is x cubed y to the fifth for both of these. So I can rewrite this right here. And up top, what do I have? 5y cubed minus 7x squared. Now, just the same as with regular fractions, we will be looking to simplify these expressions. The examples I've chosen here don't simplify. And for the most part, they kind of don't unless I engineer them to simplify. But again, this is the process. Let's take a look at a more complicated example. Here, I have 2 over x squared minus 9 plus 3x minus 4 over x squared minus 4x minus 21. So I promised you that in order to do this, you would have to be able to factor. And here you see that. Now again, we'll see more examples as we get more in depth on this topic, but again, I want you to focus on this process of figuring out the least common denominator. Well, what can I see here? X squared minus 9 is x minus 3 times x plus 3. X squared minus 4x minus 21, I can determine that is x minus 7 times x plus 3. So, when I want to determine my least common denominator, think about it for a second. Again, each denominator needs to divide the least common denominator, which means all these factors I see must be factors of my LCD. I need x minus 3. I need x plus 3, certainly. They have that in common. And I also need x minus 7. then I can see that yes, these denominators each divide that common denominator. Now I'm going to look and say, okay, what do each of these need? This is missing x minus 7. This is missing x minus 3. So now I want to consider what happens when I combine these. So what am I going to do? And now I'm going to write these. It's going to be easier, generally speaking, to look at them in factored form, so that's what I'm going to do. X minus 3, x plus 3, 2. And I multiply in x minus 7. X minus 7. Here I have 3x minus 4. And down here I have x minus 7, x plus 3. What factor was I missing? X minus 3. Alright, so when I'm doing this, of course, you need to be aware that this is going to require the multiplication of two binomials by FOIL or some other method. So be aware, that should have parentheses around it. But at that point, I can see that yes, I do have a common denominator. So I can write them over a single denominator. The order you write the factors in is, of course, completely immaterial. It doesn't matter at all. And up top, I have 2 times x minus 7 plus 3x minus 4 times x minus 3. Now again, you can expect that as we go more into this, you will do examples just like these. I want you to know how to find that least common denominator right now, though. What is this up top? I'll go ahead and show you how to simplify this. Well, this is 2x minus 14 over there. When I take the product of 3x minus 4 and x minus 3, what do I get? Well, I get 3x squared minus 4x minus 9x is minus 13x plus 12. And then, of course, I'm going to combine those, which would then give me a final answer of 3x squared minus 11x minus 2 divided by x minus 7, x plus 3, x minus 3. Again, as we work more with these, we will try and look to factor this. This polynomial is not factorable, so that wouldn't be an issue. But I would look to factor this to see if there are factors common to the numerator and the denominator, because then I would be able to simplify. But again, I want you to be thinking about how I find that least common denominator.